All right, everyone. I am here with Meg Mitchell, an AI researcher, and Emily Bender, professor at the University of Washington. And we are here to talk about their recent paper on the dangers of stochastic parrots. Can language models be too big? Meg and Emily, welcome to the TWiML AI podcast.
Thank you.
Thanks, welcome. Thanks.
Super excited to jump into this conversation. Let's start out like we always do with having you share a little bit about your backgrounds. Meg, we'll have you go first.
I basically studied as a computational linguist like Emily. I got my PhD in computer science. And then I've worked at Johns Hopkins, Microsoft Research, and most recently Google Research. I've worked on computer vision as well as natural language processing, computational linguistics, and more recently issues of bias and fairness and ethics in AI.
Awesome. And Emily, you were on the show not too long ago when we talked about is linguistics missing from NLP research? Give us a little bit of your background and maybe a catch up on what you've been doing for the past year.
All right, thanks. And I just had to close my window against the sun. So like you said, I'm a linguist, studied linguistics at UC Berkeley and then Stanford. And then I got to come to the University of Washington and start the professional master's program in computational linguistics, where Meg was a student many years ago now. And I got to know her then. So I work, largely in linguistics and computational linguistics, but since about 2016, I've also been working in the space of, I've tried to avoid the phrase actually ethics because it sends people down these paths into philosophy that I find somewhat less helpful, but societal impact of NLP. And in that context, a lot of the same discussions are relevant to other things that fall under the umbrella of what gets called AI. In the past year, I have continued that work and had this great opportunity to work with Meg and other members of her team, and in particular, Dr. Timnit Gebru and a PhD student of mine, Angie McMillan-Major, on a paper looking at the impact of large language models. And we started this in September and submitted it in October, and it's the first paper I've ever written that has been far more work after it was finished than writing it in the first place.
Maybe a sign of success.
Yeah, we should probably come right out and say that there has been a lot of conversation about this paper. A lot of that, unfortunately, for reasons that we're not going to go into here. But we're going to focus on the paper and its importance. But I'd love to hear kind of the backstory and how it all came together. What was the genesis of this work?
So the genesis for me, sort of where I came into it, was a Twitter direct message from Timnit, who said, "Hey, have you ever written about this, or do you know of anyone who has?" And I said, "No, sorry, don't have any particular papers that I've written or anything to point to. Why?" And she said, "Well, I keep having these conversations where people would like resources about what are the possible dangers of large language models, and I've been pointing them to your tweets." And I thought, okay, which tweets? And she sent me some links. But then I said, well, here's the dangers that I can think of. And it started feeling like a paper. And so a couple days later, I sent her an outline for the paper. And I said, hey, you want to write this? And this was early September. It might be good to submit to FACT, deadline in early October, kind of close. She said, I don't know, that's kind of close, but let's see. And so we put together this overleaf document, and Timnit brought in some people from her team, and I brought in my PhD student, and everyone just started contributing to the outline and filling bits in. And it was this group of people that had a really richness of diversity of scholarly backgrounds. And so we were able to draw on literature from many different fields, and it came together just remarkably quickly. We got it submitted in time, and I guess the rest is history. But that's how it's gone from my side.
How about you, Meg?
So on my side, Timnit and I, we're both working Google internally on operationalizing AI ethical procedures, basically. And part of that is figuring out harms and risks of different technologies and being able to transparently report them. So I've had this thing I've worked on called model cards, where you have to have some sense of intended use and also unintended use and the sort of potential harms associated with those. Emily has something similar with data statements. And we were really trying to get to a point where we could provide good consulting on these kinds of technologies. OpenAI was asking for information. Internally, there was just a ton of desire to have basic technologies associated to benefits, harms, and risks. And so I really thought that language modeling is so fundamental to AI. We're seeing it more and more across the board. We really need to do a due diligence task for the harms and risks. This will help us with further operationalizing ethics internally. This is critical for any self-regulation argument that a corporation wants to make about AI. They have to demonstrate due diligence for harms and risks for various technology. And also, I wrote my PhD on language generation. So if Timnit didn't include me, I was going to kill her. Yeah, so that was what happened on my end.
So the kind of framing for the paper is on language models and the increasing size of language models. Maybe let's start with that in terms of, for background, tell us a little bit about when you think about language models and kind of the size, what are the examples that come to mind, and, where do you see the trajectory going?
Yeah, so I think the first thing I want to do is give a little bit of historical context. So language modeling is a really old core technology in natural language processing. It goes back to ideas that Shannon had about the distribution of words and text and the probabilities of, given a substring, what comes next. And you had language models as a core component of speech recognition. And then the very first statistical machine translation systems also used language modeling with this. So using the noisy channel model, which goes back to Shannon. And this is a wonderful, ridiculous idea where with speech recognition, it's like, okay, the person had some underlying thing they wanted to say in their mind. It got pushed through this noisy channel of the vocal apparatus and then the acoustics in the air, and then our ability to capture that. Let's guess what the most probable underlying string was, given that noisy output. And it's done in two parts, looking at the probabilities of a underlying string giving rise to certain acoustics, and then also just the probabilities of that string being a good string in the first place. And that probability of the string being a good string, that's the language model part. In machine translation, it's kind of ridiculous. The metaphor was, okay, let's take this idea from speech recognition and apply it to machine translation. So those people speaking French really had English in mind, and it went through a noisy channel and came out as French instead. What's the most likely underlying English? Which is a stupid way to think about translation, but actually, was useful and worked well. So that's like old school language models. And initially it was just, okay, probabilities of one word at a time, unigrams, bigram probabilities, given one previous word, what's the distribution of likelihoods of the next one, up to 3, 4, 5. I think I sort of maxed out at about 5 or 6. Meg, do you know, with the n-gram language models?
Yeah, it starts to become, it looks somewhat fluent at 4, but then you realize that it's like syntactically and semantically completely nonsense. Yeah. And then 5, yeah.
And then it just gets really, really hard to just hold on to all of that data if that's the model that you're using. And so that was sort of an important piece of things in these tasks that involved manipulating language form and coming up with fluent sounding strings. And so just generating from a language model, like Mike says, you sort of like sequences of any window of 4 words kind of makes sense, but longer than that, it loses coherence. But if you're using that to select among outputs that came from something else, like in translation or speech recognition, it's really quite useful and helpful for smoothing things out. The big change that happens, though, is neural nets come into this space. And so instead of just saying, what's the probability of, the next word given the previous 1 through 4, it starts instead being this task of predicting words using a much more elaborate predictive structure. And I have to say, this is outside my expertise. Like, I know the sort of from the outside, what you can put into a neural net and what you can get out of it, but to describe what it's doing on the inside, that's not mine. Maybe Meg, do you want to say a few words there?
I was just blown away by how efficiently and elegantly you explained the noisy channel model. I was just still appreciating over here how well you did that. But yes, I don't know that I actually have much more to add than that. I think that you captured a lot of the important basics.
And I don't know that we need to turn this into a tutorial on transformers, because that'll take more time than we have.
All right, so transformers exist, and the result of that is that you can talk about words in terms of their embedding, right? So the transformer allows you to say, okay, for each given word, I'm going to talk about it not as a string, but as a thing in vector space that represents what other words it co-occurs with. And then the next generation transformers is not only that, but I'm going to represent it slightly differently depending on the context I'm looking at it in. So we get more and more elaborate representations of words that represent more and more information about what other words they've co-occurred with. And then these language models go from being something that's useful for basically re-ranking outputs to a useful representation of words in place of any other spot where you would use a bag of words model. And so they start being just ubiquitous, starting around 2016 or so in the NLP literature. So I was program committee co-chair for Coling, which is one of the international conferences in the space in 2018. And by then, just the vast majority of the submissions were using word embeddings in some way in the text.
Is that starting with like Word2Vec?
Yeah, exactly. Word2Vec and Glove, and there's one other big one in that space. And pretty quickly, like as that's coming in, you've also got the start of people looking at, okay, but what kind of biases are these picking up? Like there was not a lot of lag between everybody starting to use them and a few people going, hold on, what are we learning, quote unquote, learning about the quote unquote world by representing words in this way? And so the Bullock-Lassie et al. Papers in 2016 and the Caliskin et al. Papers in 2017. So that happens pretty quickly. And then there's one more step with the large language models, which is the title of the GPT-3 paper. It's something like language models are few-shot learners. So we go from the old-style Ngram language models being just a component that re-ranks things in the noisy channel model setup to language models providing us word embeddings that give us representations of words across many, many tasks to the language model does the task. And for the language model to do the task has to be recast into a language generation problem. Given some substring, which is the prompt, what comes next is the answer. And that is sort of a neat parlor trick. Like people were really impressed with GPT-3, but it is parlor. I say parlor trick, and we say stochastic parrots because you can throw these large language models at tasks that are meant to test for understanding, and they can be right an interesting amount of the time without actually having understood anything. And they get there because of scale, and the scale is both the amount of training data that they've ingested and also the sheer size of the number of parameters that allows them to model that training data very, very closely. So that for a surprisingly high amount of the time, given all those inputs and the parameters to model them, they can spit things out. So that's sort of the trajectory about size, but concurrent with that, the domain of application of the language models has expanded.
Mm-hmm. And so we've got these very large language models now that take many weeks to train on gigantic data sets. And one of the critiques that you mentioned in the paper is one that we've covered here on the show as well in the interview with Emma Strubel, is the kind of energy cost of creating these things. What did you learn about the energy elements of this?
What we learned was, so we looked at Strubel et al. 2019 and a couple more recent papers also making similar points. So echoing what Strubel et al. Said, which is this is big enough now that we need to think about it. That it's not just let me pull out my calculator and use a little bit of the energy that's in that battery there to ask a question, but rather it's at a scale where if you're going to start one of these experiments, it's worth asking, okay, is this worth it? Right? This has a cost associated with it. And the trouble is that the cost is in the form of an externality. So the company running the experiment, yes, they have to pay for the energy, but they are not required by law in the US to pay for the carbon costs. I know that many of the companies do strive to be carbon neutral, and so they are probably doing offsets somewhere. But the engineer making that decision doesn't necessarily know that, right? And I think the main thing that we contribute in this space is to bring in the discourse about environmental racism. So this is a cost-benefit analysis where the people paying the costs and the people getting the benefits are not the same people. And in particular, in the case of language models, there's this added angle to it, which is that we aren't building these ginormous language models for each of the 7,000 languages on Earth, right? They're getting built for English, Chinese, maybe a couple other languages. And so even at that scale, you can see, okay, who's going to benefit from this? Who uses this technology? And we point to some of the places in the global south that are getting hit the hardest with the current effects of climate change. The people there are not anywhere close to getting any benefits from this technology. But you don't even have to go look so far afield, right? I mean, environmental racism exists within the US as well. And if you look at language models and what language varieties they target the privileged standardized language variety and not the language that is, belongs to the communities that are getting the hardest hit with the environmental impacts. So that's, I think, the new thing that we added was bringing those discourses together and saying this matters here too.
Mm-hmm. There's a comparison in the paper. I don't remember if it came from Emma's paper about training a BERT model and comparing it to like a cross-country flight in terms of its carbon output. Did you come across any sense, or do you think we have any way to know, so that's an individual training, how much of this is happening at scale across companies? Part of what these models are offering is kind of the transfer learning idea that you can train them once and then lots of people can have the benefit from them. Do we know as opposed to kind of a relative sense of the energy cost or environmental cost, like what the absolute cost looks like?
I'm afraid I don't know. I mean, we have some numbers that we've quoted in the paper, and those come from Strubel et al. It's not our own work. And we also, this paper was, co-authored by people then at Google and people at the University of Washington, but we did not try to do any investigation internal to Google about, energy use or things like that. We were just making the broader point that it's time to think about this and not just assume that this is something that happens only in some abstract space. It actually happens, in the physical world as well, and that has impacts.
Yeah.
I'll just maybe add that part of why this is important, it fits into this growing trend in talking about ethical AI or aligning AI to human values, about understanding the context around usage. And so we're talking about who's using it and how they're using it and what's happening. And that's where you start seeing things like environmental considerations as well as societal impact, because now you're thinking outside of the model itself, outside of the learning itself. And so this is also reflecting just sort of this general trend that I think a lot of us are aligning on as we think about, creating more ethical technology, which is what is the context and what are the considerations of that context. And that's part of what we were trying to do, by pointing to the Strubel paper and the details there.
Mm-hmm. So you talk a little bit about this environmental piece. You reference that there, part of the what's been requested or asked of industry is to just make clear like what the cost of these various experiments is, and it doesn't sound like there's been a ton of progress in that regard, and companies kind of voluntarily publishing or companies or even in academia, folks voluntarily publishing the energy or financial costs of these models they're running. Any updates in that regard?
I think this might help the case. I mean, I worked forever trying to get Google to publish evaluation numbers across different subgroups. And after years, finally finally was able to make enough inroads where Google was doing that. But that was only helped by people externally and activists showing that this is what we need. So I think that, perhaps unintentionally, Google has now focused a lot of attention on the need for transparent reporting of this kind of stuff. So I imagine we'll start seeing it soon.
Yeah. And I just want to say that there's some levers. So for the NACL 2021, I'm actually co-chair of the ethics committee, and we put together this FAQ of these are things you should be considering. And one of them is environmental costs. So if you're running something that involves a lot of compute, describe that and say something about what is the actual environmental cost of this approach that you've taken, so that somebody else picking it up would know. So at the point of publishing a paper, there's this notion of, okay, we need transparency here. The problem is that not all experiments become papers. And so getting to sort of an accounting of all the things we tried that didn't work, like where does that go? And so I think they're having both sort of the general, reports from companies about their efforts to becoming carbon neutral, and not just becoming carbon neutral, but the overall energy use. Because one of the points that comes up is you can do a whole bunch of computation based on solar electricity. And so, your computation has not put any carbon into the world. But if you weren't doing that, someone else could have used that solar power to, do something that is actually life critical, as opposed to another tweak on the experiment. Oh, we forgot that parameter. Let's try it this way, kind of a thing. Mm-hmm. So
it makes me think of, there are, in pretty much any, subcategory of industrial activity, there's some analyst firm out there that's, building up a model for, what the total addressable market of this thing is, often kind of bottoms up, looking at individual companies and what their revenues are, things like that. It seems like someone could and should be doing the same thing to try to give us a sense for, what is the total economic impact or environmental impact, rather, of the AI industry. I've not seen anything like that, but it would be fascinating to, even if other models, it was wrong, it would be insightful to get a sense for what the scope and scale of it might be.
Yeah, absolutely.
Startup idea.
Yeah.
So one of the biggest contributions of the paper is really talking about the bias implications of these kinds of models. Meg, why don't you get us started off there? What, how do you think about the, large language models and the bias implications of them?
Yeah, I mean, one of the things to keep in mind is that you have errors in these models that then are deployed at scale all over the world. I think one way to understand this is similar to the gorillas incident that happened at Google, where that might have just been one mistake, but it's one mistake that's the same mistake all over the world, reflecting a very problematic, horrible historical prejudice. And so you have the same sort of thing with language models, where even if it's one mistake, it can affect billions of people, and in the same way. So you're very clearly driving a line between, the normative sort of world we want, and then these specific biases and stereotypes and aspects of racism and things like that. And so this is one of the reasons why, you have to have like a critical look at how well these things work in different situations, and what kind of things they produce, in order to have some sort of sense of what's going to happen when you deploy it. The problem is, which is part of the paper, is that these things are so big that it's really hard to know. So you kind of don't find an issue until suddenly people are being harmed by it. And so this is why we need to think very critically about how we build up these language models, so that we have some sense of how it might perform, and particularly with respect to things like racism and sexism and what it might, further reify unintentionally.
One of the kind of recurring arguments in AI Twitter, and we've talked about it on the podcast as well, as kind of this idea around bias in these models coming only from the data versus the other aspects of the system, the architecture of the models themselves. Emily, you and I may have talked about this last time. In the case of language models, we talk a lot about the data being the source of bias. Are there, how is that kind of conversation of the broader sources of bias? How does that play out in terms of language models?
So I think that, first of all, I just want to go on record as saying that I think that this no, it's only in the data move that sometimes people make is really just a deflection and a way to say, to try to carve out a space where if all you're doing is working on architecture, then none of this is your responsibility. And it's just not true, right? Mm-hmm. So if you want to think about, how does learned bias in some sort of machine learning model cause harm in the world, then all the pieces matter. So what's in the data, how the data was collected, how the data was documented. Can you actually tell what's in the data? The model itself. So what's it learning from the data? To what extent is it sensitive to, outliers versus high frequency things? There's model parameters there. What were you optimizing for as you were training the model and designing the model? And then how is the model sitting in its deployment context? So at every step of the way, there is part of the story of how bias in the data can end up as harm in the world. And so, to a certain extent, if we could come up with a completely clean, and this does not exist, completely clean, unbiased data set, then what the rest of the steps did wouldn't matter as much. But also, if you could come up with a model that was somehow impervious to learning bias, which is equally impossible to coming up with an unbiased data set, then it wouldn't matter what bias is in the data set. So, it's everyone's got a responsibility, and trying to say that's not my problem is being part of the problem. So
I just realized that for people working on architectures and machine learning and optimization who say it's the data, it's the same argument as, it's the pipeline problem for diversity in tech.
Hiring and diversity.
It's what happened before. I have no part. This is from before. But also speaking to that, to what Emily's saying and the interplay between data and model, your choice of loss function minimally is packing in normative decisions about how the model should behave. So you use something like L1 loss, L2 loss, which is super common sort of across statistics and especially in machine learning. You're making the value judgment that different kinds of errors are basically the same because they use absolute measurements. So even these very, very basic fundamentals of machine learning pack in value judgments about how to treat different kinds of errors. And that really affects what the model will learn and how it will propagate different kinds of issues.
Yeah, I'd love to maybe dig in a little bit deeper and make some of the harms or potential harms of language models more explicit. I think, before we got rolling, we talked a little bit about, bias being a bit of this ginger word that we use that isn't particularly pointed about the outcomes of the bias. One of you want to elaborate on that? Who wants to jump in first?
I'll have a go at this one because I feel strong about it. I know Meg does too, and so she'll probably jump in too.
You always say things better than me, so.
Thank you. I don't think it's true, but thank you. So what do we mean by bias in the language data, first of all, right? And that is basically a wide range of things, starting with slurs and overt hate speech to sort of the subtle framings of things that can include, the discourses that we have in this country, where you can see that different. So people who are experiencing oppression will come up with new words to describe their experience that push back against what the oppressors are saying. And so you see this in pairs, for example, between undocumented immigrant or undocumented person versus illegal immigrant or worse, illegal alien. So those pairings. You also see things like, how often outside of the Twitter account man who has it all do you see the phrase male doctor, right, compared to female doctor? So there's these phrasings that basically say this is what's normal or normative and this is what's marked. So these are like this full range of things that shows up in the language data. Put that into a language model and think about how you're using the language model. Are you using it to randomly generate text in a fun chatbot? Well, is that fun chatbot going to be either spewing overt hate speech or just sort of going along with the various systems of oppression and saying things that are sort of vaguely racist or vaguely misogynist, but a little bit dog whistle under the radar? And then the people who are reading that are either experiencing the direct effects of that denigrating language because it's their own identity that's under attack. Or if it's not their own identity and they're not very alert to what they're seeing and sort of ready to look at it with a critical eye, it might be just sort of getting things subtly reinforced and then be prepared to go out in the world and say similar things themselves or act on these ideas that are harmful. So that's sort of one version of it. But also language models get embedded into other technology, right? And they can become part of classification systems that basically then say, well, we associate all of these high-paying, high-prestige professions with being male, and so therefore we are going to find this resume a better match for this high-paying profession because it's got these other markers that are associated with being male. It's one example. But also, this is what Safiya Noble was documenting in her Algorithms of Oppression book, and I'm just looking down here because I have it. I'm going to put in a plug for her book. There it is. So, on the cover of this book, she illustrates what happens with search engines by putting in the search prefix, why are Black women so? And then the search engine that she's using, which based on the colors of the textbook is probably, or the colors of the book cover is probably Google, completes it with angry, loud, mean, attractive, lazy, annoying, confident, sassy, insecure. And so you sort of see all of these societal stereotypes that have been pulled into the search engine and exposed through this, what might you be searching for here thing. And I want to say, just sort of as a footnote, that I don't know for sure how this product is created. And so the search autocomplete might be using language models differently or independently of how the underlying search engine is. But
there's
the technology
a stealth word list now, so not going to have angry.
Not going to have angry. All right. So anyway, these are ways that these biases that can either be overt or subtle can happen. And there's one more that I want to flag that William Agnew pointed out on Twitter, and I thought this was really smart. And fortunately, he pointed it out while we were still working on the paper, so we were able to incorporate the idea and credit him. Which is, there's this list, Meg says, stop word list. This is a different one, I think. The list of obscene, offensive, and otherwise very bad words or something. And it was initially created by an engineer somewhere who wanted to avoid this problem, wanted to avoid search strings coming up and shocking people in the context of, I think, music recommendation. I'm not entirely sure the backstory there. And so it's got a few racial slurs and then a whole bunch of words that basically whoever created the list thought would be associated with sites to do with pornography. This is now actually used in filtering the underlying data for large language models in English. Basically use this word list to drop any website that has these words on it. Which, okay, good first pass at getting rid of, the overtly white supremacist websites. Okay, that helps. Like that was not a negative thing in itself. But in addition, there's words like twink on this list. And so you end up ruling out all of these spaces where people are speaking from their own, LGBTQ identity and speaking positively about their lived experience or positively about their identities and negatively about things that they've experienced. And that stuff gets removed from the language models. And so you've got this now sort of amplification of the rest of the language that is either indifferent to or negative towards LGBTQ people getting sort of boosted in the training data. And then, downstream effects. What does it mean for someone to be this? What kind of search results are we going to see? What kind of sorry, search results are my only example top of mind right now. But everywhere you get a language model embedded, what kind of mistakes are we going to see in speech recognition, right? Where certain words are super low probability, or certain sequences are very low probability because of what was taken out of the training data. And now we can't recognize it and portray it accurately. And so instead, we're going to say something ridiculous that in context could end up being quite offensive.
Yeah. So. I only have maybe a slight add-on. Emily talked about ways of talking about people that can be sort of othering, like saying illegal immigrant. And I think one of the things that really sticks out for me in that is how when you add different kind of modifiers to words, especially words about identity, how that can be very othering, or you might call it sort of marked. So saying that this is an Asian woman or, a Black person instead of a person or a woman gives it this like, not quite a person, but a certain type of person vibe that isn't there with a white default. And so you see this coming out in things like captioning models, any sort of generating from images, where these sort of trends, if you're trained on data that is predominantly from white websites and people, with white experiences writing about their experiences, then you're going to call white people people. And you are going to call Black people, Black people. And so these even just very subtle things can really create an othering in society that you don't even really know if you're not paying attention.
And I think that othering ties right into the work that people from marginalized identities have to do to just prove their validity as humans all the time. Right. This is something I hear over and over and over again, is I am spending all my energy proving to people that I am a person and therefore have a right to have an opinion and exist and be respected. And that is directly connected to this othering that Meg is talking about. And we don't need computers helping us do more of that.
Yeah. Right. You also reference in the paper the kind of even, from the title of the paper, Stochastic Parrots, this idea that we tend to think that these models we give them qualities that they don't have, like understanding and reasoning and the like. What do you think are the implications of that? How does that play out in the use of these models?
So Meg, I want you to take this one.
Sure, yeah. So the human brain is amazing, and we are very good at anthropomorphizing. There's a famous illusion called, I think it's called the Hyder-Simmel illusion, where if you have this little video of a triangle and a circle, and the triangle is moving around all rough and the circle is moving around all slowly and lightly, you create this whole narrative about the triangle is a bad guy and trying to attack the circle, and the circle's a good guy. But these are just basic lines, right? And so if we can do that with basic lines, imagine what we're doing when we see something that looks like actual language. We really believe there's a mind there. Even when we tell ourselves rationally there's not, we still are imbuing it. We're still seeing it. And this isn't just because we're good at anthropomorphizing per se, but because language in particular is something we've evolved with as a way of communicating and understanding one another's intent. So we're in this position where we've actually evolved to see this illusion and to experience it in a very human way, that this is fundamental to our understanding. So it can be a pretty tricky issue there, especially when it comes to things that could be like bullying, harassment, other kinds of really problematic language that could come out of language models, and you start to really think it's real, you start to feel that way. Improper medical advice, there's so many things that you can now misinterpret, misunderstand, have wrong information about, feel terrible about, because you have a sense that there's some mind here that's telling you something, but it's not.
Are most of the uses of language models that you've seen kind of in the wild noted that it's a language model? I guess, I'm thinking a little bit to conversations around like, we impart a level of authority to computers and robots and the
automation bias.
But I think on the other hand that most uses of language models, like, you don't really know, like even a chatbot, like, we name our chatbots, we give them personalities, and we try to hide the fact that they're computers. Does that mitigate the, this effect that we're talking about here, or does it accentuate it?
It exacerbates it totally. I mean, so as Meg was saying, we are prepared as soon as we see language to imagine a mind on the other side of that. And what's happening is that mind doesn't exist except that we've created it, right? The listener is the one who creates the phantom mind there, and it was really, there's great potential for harm. There's a startup in France that ran this study asking whether GPT-3 could be used for medical applications, and sort of ran a whole bunch of different tests of ways they might imagine using it. And one of them was a mental health chatbot, right? Mm-hmm. Why you would want, you don't want even an untrained person handling sensitive, discussions with somebody who's in distress, right? Let alone a machine who's just going to randomly say things based on previous patterns. And of course it comes out with suggesting self-harm, right? And my reaction to reading this blog post was, what gave anybody the idea that this might be a reasonable application of this? And there, I think it really comes back to AI hype, that people build these things and it's a cute parlor trick, and we are way too fast to say, look what this thing can do, and way oversell what's actually going on. And this is what I was talking with you about last summer also. But I think the article that GPT-3 must have been after that. I don't think that this thing from France had been out at that point. But it's really, really, really important to keep both the specific instances labeled as this is a computer that either knows nothing or only has access to these possible actions it can handle for you. And then in general, having a very clear idea to the public about this is not, in fact, intelligence of any sort. It is just pattern recognition at scale. And we need to think about what are the decisions that we want made based on pattern recognition, and what are the consequences of reproducing the patterns that it will recognize, even if they're not there, because it's reproducing the patterns from its training data.
I want to also piggyback on something you said, Emily, which is talking about how using something like a language model for health information is a function of AI hype. I've worked a little bit, or am somewhat familiar with crisis lines, and it's not just hype. There's a lack of people. You need, if you want to have sensitive conversations with someone, and just be available on the spot, you need a lot of very, very highly trained people. And maybe that's possible in Denver, but it might not be possible outside of, more outside of very well-funded cities, right? Mm-hmm. So the idea with automation in at least crisis helplines is that you can start standardizing, bringing in people who are less trained, but they can have access to potential responses and sort of standardize across them. And so now you can have more of a sort of help chat where you press different buttons when you're the helper, you press different buttons and then different things will be generated. So there is an actual need for helping professionals in these contexts. And then the problem is, what is the foundation from which you're helping them? And that's where the language model insidiousness then comes in, right? Because you're going to be drawing from some language model in constructing these larger systems used for very sensitive purposes. And there might be a person involved, if you're lucky. And even then, they're not necessarily going to be making the right decisions if they're already given really problematic input to choose from.
Right. And they might therefore themselves be subject to this machine bias. Well, the machine suggested this might be a good response, right? So yeah, I think it all comes back around to there's definite uses for pattern recognition and places where we can use automation to fill in the gaps where we don't have enough resources to hire enough humans to do the work, or the humans. I mean, it's also really difficult work, right? You could have all the resources in the world and you might not find enough people who are willing to do it. Yeah. So the question is, how do we create something that is well fit to its context and really built with the population that it will come in contact with in mind, both the, in this case, the humans that are choosing among the responses and the people that are calling in and talking to them, or chatting in, I suppose, and talking to them. Is this system, based on a bunch of actual therapy chats that involved, only white people or only wealthy people, and then you deploy it as the municipal helpline, and you get a much broader range of people who've got very different lived experiences and are going to talk about it in different ways. Has it been tested actually in that context so that it can be as helpful as possible?
Mm-hmm. So the paper is primarily asking questions and prompting people to think about these models, but have you come across examples of practices that you think will help, or examples that give you hope, or things that we should take inspiration from? And what do those things look like? Is it curation? Is it carbon offsets? What are those things?
Yeah. So one of the sort of common points that we started from in doing this work, so as Meg mentioned at the beginning, she had worked on model cards, and Timnit was on that paper too, right? And Timnit had, are you on the datasheets paper as well, Meg? Are you both on both of those? Okay. So Timnit had also worked on datasheets, and at the same time, I was working with Batya Friedman on data statements. So all of this is about documenting underlying data sets and transparency. Exactly. Documentation and transparency. And one of the practices that enables documentation and transparency is keeping things scaled to the size where you can actually do it. And so we talk in the paper about a concept of documentation debt. And I was feeling really special for having come up with that term. And then I thought, I bet you're not the first, Emily. So I went and did a search. And sure enough, people talk about documentation debt. It's a thing. But the idea there is, if you get to a place where your underlying data set or your model trained on the data set are so large that it can't be documented post hoc, then you are putting yourself at all kinds of risk for doing harm that you can't predict, that you can't trace back, that you can't fix. And so, one of the practices that we suggest is budgeting for documentation at the start of a project and only collecting as much data as you can document. And that's the appropriate size. And that's our question when people say, well, okay, how big is too big? You're telling us that they can be too big. Where's the bar? And it's not one single number. It's too big is too big to document. Because once it's documented, then you have this hope of saying, okay, how's this going to fit in my use case? Is this appropriate for the decisions it's going to be making, the context it's going to be in, the people it's going to be coming in contact with? So that's documentation is one set of practices. But there's others as well. So this idea of a pre-mortem, and Meg, could you speak to that one a little bit?
So a pre-mortem is when you think of what could go horribly wrong, and then you walk through what chain of events could have led to that horrible ending, and try and find solutions to that before they happen. There's also a similar idea called the DIRT test in programming. Sorry, is that
yeah.
That makes me think of Amazon famously writes these press releases before they start developing a product that kind of guide the development of the product. The pre-mortem sounds like maybe the ethics version of that, where you write,
that's right,
what could have gone wrong, and use that to guide how you avoid that.
Yeah, exactly. So you write the scandal that would hit the papers, and then figure out how to avoid that.
Don't do that scandal. Yeah.
And this is, I think, connected to, there's this idea from value-sensitive design called design noir and value scenarios. So this is, let's write stories. Let's think about, what could happen. And the practice there is to say, all right, what if you hit the jackpot and your product becomes completely pervasive and everybody's using it? right? How does that change? If once it becomes part of the infrastructure of society, what changes follow? But also, what happens to, think about specific vulnerable populations? If everybody's using this product, then, what happens to somebody who, doesn't have a smartphone? Or what happens to somebody who's, it's all voice activated, but somebody's got dysarthria and they can't speak clearly enough for the system? Can they still get on the bus? Or sort of thinking through these things. So and then there's one thing that I keep seeing on Twitter, and I don't know who to cite for this, but this is for every piece of technology, one use case that you should keep in mind and try to thwart is what would happen if this was, how would somebody who is an abusive ex-partner use this to stalk? What's the potential there? And just that use case is frequent enough. It's a frequent enough sort of downfall of various kinds of technology that it's worth just sort of thinking that one through early on. Now, I don't know how to connect that to language models, but coming back around to your question of practices, a lot of this has to do with sort of situating everything in context. What are we trying to build? Who are we building it for? Who else might use it? How do we plan to deploy it? And sort of taking that mindset rather than the, hey, fun, we're playing, let's build something and figure out how to make money off of it later kind of approach.
There's this point you made about being too big to document and that being part of the problem. I think there's also an important point to make here about normative versus descriptive approaches in language modeling, where you could think of a way to create a data set being you define the requirements of that data set. What are the characteristics that data set should have? Let's be very clear about these. And now let's get the data that matches the requirements. So that's sort of a normative approach. A descriptive approach is let's just take whatever and just call it the data we need, which is actually the state of the art approach right now. Let's just take whatever. The idea of having data requirements is new. Insane. And so I think it's really important to sort of keep in mind with this idea of being too big to document, that part of that is that we're just collecting things from wherever. We don't really know what it's conveying. We don't really know what's going on. There's no sense of getting things that specifically, are useful for some normative considerations. It's rather, let's have the internet define what's important. What did go wrong?
And there's this idea that the internet is everything and everybody. Right?
That's the perfect representation of all of the world.
Yeah. And it's absolutely not. If you dig into the studies, and this is part of what we do in the paper, I think it's section 4, and basically saying, okay, who's actually participating in the internet?
Yeah.
That is already people who have more privilege and more resources. And then who is participating in the sites that are chosen for the starting point? So a lot of this actually starts from Reddit, not Reddit text itself, but websites that are linked from Reddit as, well, these must be high quality. They've been linked by Redditors. And there's a study that we cite in the US that looks at sort of a survey of Redditors in the US and finds that it's mostly people in the 18 to 34 age group and also mostly men. So you've already sort of narrowed your view of whose views are we taking on. But then on top of that, who gets to participate comfortably in online fora, right? Who's subject to harassment? Who's going to get harassed off of sites versus the people who tend to get away with harassment and stick around, right? So there's the further narrowing. And then that list of obscene, et cetera, and otherwise very bad words I was talking about is yet one more narrowing. And so this notion that we are just grabbing what's out there, that's just how the world is, we're only reflecting that back to you, just isn't true, all right? And on top of that, so linguists very much like to be descriptive and not prescriptive. We're very much about, language is a natural phenomenon. People talk the way they talk. All language varieties have inherent value. You can quit it with your stop splitting negatives type prescriptive rules. But that's because linguistics is engaged in describing language as it is. And machine learning models that are deployed in contexts that are either making decisions or helping people make decisions are not just describing things. They are affecting things. And so even if we've just grabbed a perfectly representative sample thing worked, we still wouldn't want to deploy that because that's not a job for description. It's a job for careful engineering and some normative thought.
Wow. There's so
really
much
Thanks, Emily.
I've got so many more directions I want to take this in, but I'm also looking at the time here and want to be respectful of your time. How about a round of kind of parting thoughts or words for the audience, things that you'd like them to consider?
So one thing that came up in the fact Q&A, so the fact conference Q&A about this paper, that I've been sort of sitting with and I enjoy, is this idea that specificity has real value. There's a lot of value placed both in academia and in industry on scale and generalization and trying to make things bigger and bigger and bigger and applicable across more and more contexts. And I think that it would be worth reallocating some value to building solutions that work really well in their specific context, where the context includes the task and the users and the other people who are affected by the use of it. Because when you're working at that scale, you can bring in the sort of care and considerations of impacts that really just get overwhelming if you're trying to do a thorough analysis of what are all the possible specific harms we need to mitigate in this one enormous general purpose thing. So I want to put in a plug for context specificity and working at smaller scales.
Mm-hmm.
Yeah, I guess maybe one of my imparting thoughts here can be about considering the trade-offs when you try and mitigate different types of biases. So, a naive takeaway from this discussion might be, oh, well, we should figure out how racism is expressed, how sexism, how ableism is expressed, and then tell language models not to do that. The problem you have to immediately start thinking about then is dual use. Once you have explicit details about racism and sexism, particularly as it relates to language models, then that in itself can be weaponized. So there's always a very difficult balance between being clear on the sort of racist and sexist things you don't want your technology to do, on the one hand, and B, making explicit the exact things that can be harmful to people in a way that can also be deployed at scale, or even applying stereotypes in order to categorize them as such. So there really is a tension here about doing the right thing by mitigation versus coming up with other metrics or specific requirements in data collection. So, naively just saying, don't say racist things has with it a lot of drawbacks as well.
Mm. Awesome. Well, Emily, Meg, thanks so much for taking the time to chat with us about the paper. Lots of interesting conversation and definitely one that folks should read and think about.
Thanks for having us on. The paper's open access, so it should be available to everybody.
And of course, we'll link it in the show notes. And so go take a look.
Remember the parrots. Thank you.
Yes.
Awesome. Thank you.
All right, thanks.
Thanks.
Bye.